Hi, I wanted to say a little bit more about the difference between transforming upper and lower indices because I did not mention this very important distinction here. So we saw how to transform a 4 vector with our upstairs index, so our contravariant upstairs index. So we saw that in some primed frame, a 4 vector is transformed using our Lorentz matrix, like this. So that's for a 4 vector with our contravariant, or I just say upstairs index. So one of the key differences between our upstairs index and our downstairs index objects is how they transform. And this is very important. So we really need to make sure that this is down. So if we want to look at an object with a lower index, so this is referred to as a covector, we use, instead of our normal Lorentz transformation matrix, we actually use the inverse in this case. So now we have nu, mu, a, nu. So this is for our covectors. So for upstairs, objects with upstairs indices, you use our normal Lorentz transformation matrix. For downstairs indices, so we're still going from the unprimed to the primed frame, but we're now instead transforming a downstairs index. And so we use the inverse matrix for that, which could feel confusing. But the more you do it, the more you'll get it straight. So those are for our simple sort of 4 vectors or covectors, so our rank 1 tensors. Let's also make sure to be explicit for rank 2 tensors at least. So I mentioned that you need to apply a transformation matrix for each index. So let's just be explicit about this to make sure everyone knows what I mean. So let's first do it for the case where we start with 2 upstairs indices. These are both upstairs, so we just use our normal Lorentz transformation. And we're going to have 2 of them. And they're acting on our tensor in the unprimed frame. And the way we're going to fill in our indices, so we're transforming each of our indices. So I'm going to choose some new sigma rho indices. And we're going to be contracting these. We know we need to end up with mu and nu upstairs. And so the sigma and rho must be downstairs. And so we see these sigmas and rhos are being contracted with our transformation, and then leaving the mu and nu as our free indices, which is what we wanted on the other side to have this be an equation that makes sense. Okay, what if we have an object with 2 downstairs indices? Well, now each index, both of these are downstairs, so both of them are going to transform with the inverse transformation matrix. So we're going to need 2 of those. And then we can fill in, I'll use sigma and rho again. We know we want to end up with mu and nu on the bottom, and then our sigma and rho therefore must be upstairs for our transformation matrix. Okay, and then finally, what if we have something that's in between? So maybe we have some object with 1 upstairs and 1 downstairs index. Our upstairs index is going to transform with our normal transformation metrics, whereas our downstairs one is going to transform with the inverse. Okay, and again, I'll use sigma and rho as my new indices that are going to be the bound indices on my right-hand side. And so we have mu that we want to end up upstairs, and that needs to be contracting with our other upstairs index on our original tensor. And then we want to end up with the nu on the bottom, and that's contracting with our rho. Okay, so if we have an object with both upstairs and downstairs, all of your upstairs indices need Lorentz transformation matrix, all of your downstairs ones need an inverse. And you can stop the video now, but let's really bring it home. Let's just do one more. Let's consider we have mu nu delta. Let's consider a rank 3 tensor. Okay, we have two upstairs. Those both carry our normal Lorentz transformation matrix. And then we have our downstairs. So that's going to carry an inverse. And then we have T. And let's make up. So we'll use rho sigma, excuse me. And then I'll use gamma. I need another new one. So actually pause the video here. Try to fill in these indices. Okay, so we need to end up with a mu upstairs and a nu upstairs, and then a delta downstairs on our inverse one. And then our made up variables, we have a rho and a sigma and then a gamma. Okay, so and we can just fill them in like that. And I think I did it right, and hopefully you got the same thing. Okay, so that's more explicitly how to transform both vectors and covectors and then higher rank tensors, especially when we have this combination of upstairs and downstairs indices. All right.